Welcome to the internship program. I am Shubham Gupta from NextGen AI Frameworks Private Limited. I have 14 years of work experience in the fields of artificial intelligence, software development, and robotics. In this session, we will create a simple game playing AI using reinforcement learning. So let's see, I tried to create one project. So this is how it looks like. Learn automatically. This is Cardpole from gym library, Python gym. So this is from OpenAI. Okay, so what I am using is from OpenAI. So first I will show you this article that I have created. So for reinforcement learning, I created this basic article to tell you about the theory, what the thing is and how it works. So this is interactive guide on reinforcement learning, how the algorithm works. So in this interactive journey, you will be an agent making decisions on different environments. So let's dive into the key concepts, explore algorithms and get a feel of how agents learn through interaction and feedback. So this is the example how reinforcement learning works. So concept 1, agent and environment. So imagine you are controlling a robot, or in technical terms the agent, in a maze, and here the maze is the environment. So these are the technical terms, agent and environment. So imagine you are controlling a robot, the agent, in a maze, the environment. Every time you move the robot in the maze, the environment changes and you receive feedback. So every time you move the robot in the maze, the environment changes and you receive feedback. Your goal is to find the treasure hidden in the maze, but you don't know the exact path yet. So you have a maze. If you don't know what maze is, these are the maze. So for example, you are running a robot through the maze and you want to find the center point or the path, or to find the treasure hidden in the maze. This is the task for reinforcement learning. So what would you do? Explore different paths, or try to remember where have you been, or go with the gut feeling. So three things: explore different path, try to remember where you have been, or go with the gut feeling. So starting with this, let's see the activity, explore the maze. Choose an action. So what you will do, you will choose an action, up, down, left or right, for your robot to move. Based on your choice, I will tell you what happens in the maze. So state, you are at the start of the maze. So this is what state is. You are at the start of the maze. There's a treasure hidden in the maze, but you don't know where it is. So this is the situation. You can understand this easily. So action options. So what can be done? You can move up, down, or robot can move up, down, left or right. So this is the first concept of the agent and environment. And the concept 2 is rewards and feedback. So I have mentioned all these keywords here, and I am telling you step by step what they mean and why they are required in the reinforcement learning. So rewards and feedback. Each action you take gives you feedback. So each action you take gives you feedback. If your robot moves towards the treasure, you receive a positive reward. So if your robot moves toward the treasure, you receive a positive reward. If it moves in the wrong direction, you get no reward. Even a negative one, if you hit a wall or get trapped, So if it moves in the wrong direction, you get no reward. And if you hit the or even a negative one, if you hit a wall, or get trapped, then you will get a negative point, or you will get no reward. So this is what reward is: positive, negative, or no reward. Okay, so after a few moves, how will you decide which action to take next? So you understand, you have a robot and a maze, and it started moving to find the best path. So what is happening is, now you will give a reward if it goes on the right path. If it hits the wall, you will get a you will give a negative one, or no reward if in the wrong direction. So this is what reward means in the reinforcement learning. And each action you take gives you feedback. So you understand this, when you go into the maze, you look at the wall in the front. So what you will get a feedback, that this if I go to this path, I will see a wall. So that's the feedback. And if you keeps moving correctly, you will get a positive reward. Then if not, a negative one or no reward. So this is what reward feedback means in reinforcement learning. And agent and environment, I told you. So let's see the challenge. Choose the best strategy. Scenario is, you moved left and found a path leading closer to the treasure. So you moved left in the maze and found a path leading closer to the treasure. Question is, will you continue moving left, or will you explore a different direction? So exploit means move left again, and explore means try moving right. So these are the terms. Explore, as you know, for the look for the new things. So try moving right. And exploit is move left again. You are thinking that you will get to the treasure. So this is the exploit, move left again. So as you know, in the maze you can move up, down, left, right only. So four things only. So this is how it is working. And again I will show you the program. So this is automatically being done on the computer, on the OpenAI Gym that I created the project. So what you need to know is the terms related to the reinforcement learning. Let's see the policy and learning. So a policy in reinforcement learning, or RL, is a strategy the agent follows to decide what action to take. So agent follows to decide what action to take. Over time, by interacting with the environment, the agent learns the best policy. So there are two key approaches to learning: model free and model based. So model free is, the agent doesn't know anything about the environment and learns purely from rewards. So the agent doesn't know anything about the environment and learns purely from the rewards that I discussed earlier here. And if you are going for model based, the agent tries to model the environment and predict what will happen after each action. So you understand the prediction, we have created many models for the prediction. So if you go for model free, then it's purely from the rewards, hit and trial. And for model based, you can use the model that can predict the future move. Now the experiment test policy. So scenario is, your robot has explored a few paths and received feedback. Now it must decide whether to follow its current strategy or change. So the task is, if you were the robot, how would you adjust your policy based on the following observation? You went up, received no reward. You went down and the path is blocked. You went left and got closer to the treasure. So choose an action based on your policy. So as you know, you went left and go closer to the treasure. This is known as exploit, as I told you in the terminology. And if you go to, so you went up and received no reward, you are exploring the path, and for moving left exploring, for moving down exploring, for moving left exploit, because you are getting closer to the treasure. Move right, then you have you are again exploring. So these are the terms, exploit and explore. So we tested the policy using the experiment. Now concept 4 is Q learning. So in reinforcement learning, the robot can keep track of how good each action is in the given state. So how will it keep things in the memory and know what it tried previously? So this is Q learning. This is done through Q learning, where the robot builds a Q table mapping actions to rewards. So this is what Q table is. It will keep the previous records in a Q table, what it tried and what was the result. So for example, if move left often brings you closer to the treasure, Q value for that action will be high. If move up leads to a dead end, its Q value will be low. So this is Q learning. So exercise, build a Q table. So let's see the Q table. Current Q values: move up Q 0.1, move down Q 0.2, move left 0.5 and move right 0.3. So what will be your next action? Choose the action with the highest Q value to maximize rewards. So as you can see, move left has the highest Q value, so it will move to left. And concept 5, deep Q learning. If the environment becomes too large or complex, we can use deep Q learning, where instead of Q table, a neural network is used to approximate the Q values. This allows the agent to handle more sophisticated environments, such as video games or real world scenarios like self-driving cars. So all those things, deep Q learning. So in agent, you made decision for the robot. Environment is the maze responded to your action. Rewards, you receive feedback and rewards based on the action. Policies, you made decisions based on your current strategy. Q learning is you use Q values to choose the best actions. So this is the summary, and you can look for this article step by step to understand how robot is navigating the maze and finding the treasure. So you can read this article. I will continue this session in next video. See you in next video. Have a nice day.